Okay, I'm going to work on section 8.5, number 5. And I'm going to show you the four-step process to the hypothesis test. So on number 5, step 1, remember we have an H naught and we have an H1. And if you read problem number 5, it says test the claim that the population of volumes has a standard deviation, so standard deviation, less than 0.15 ounces. So we're going to remember that this is in ounces. And we'll know then that the null is standard deviation equals, 0.15. Okay, it says to use alpha of 0.05, so there's step 1. I have everything I need in step 1. Since we are testing standard deviation, step 2 is going to be the chi-square. So chi-square equals n minus 1 times s squared divided by sigma squared. So if you look at our problem here, it says a simple random sample of 36 cans. So that'll be n, 36 minus 1, times s squared, and it says these volumes have a mean of 12.19 ounces and a standard deviation of 0.11 ounce. So for s, we're going to use 0.11 and square that. Okay, so that's s squared. Divided by sigma squared up in step 1, sigma is 0.15 squared. Okay, so I want you to calculate that right now on your calculator and stop the recording and come back to it after you've calculated that. Okay, so that equals 18.822. Remember, we go 3 decimal places because of the chi-square table. Okay, so for step 3, you have to look at degrees of freedom of 35. Okay, so our table does not have degrees of freedom of 35, so you can use 30 or 40. I always suggest using the lower one. The book kind of went halfway between, but again, I'll let you decide and I'll kind of talk about that later. So draw a chi-square table or a chi-square curve, and if you look up your one-tail test as alpha 0.05 in the right tail, so if you look up degrees of freedom of 30, you're going to get 18.493. If you look up degrees of freedom of 40, you would get 26.509, and I believe the book went halfway between those two to 22 something because they just interpolated that. But again, you can go to 30 or 40. Realize if you go to 40, you're going to get a different result. That's why I always go down in data values. So I'm going to use 30 for my degrees of freedom on the table. So 18.82 is somewhere right over here, and it's in the tail, so we are going to reject H naught. So if you reject H naught, you accepted your claim. So up here in step 1, H1 was your claim, so you accept your claim. So you would say, and I'll let you finish step 4, there is sufficient evidence to show that, and you can go through the standard deviation, etc. I'll let you finish that on your own. Okay, so that's that problem.